Hello again, everyone. In 6C, which is what we're up to now, we're going to have a look at a couple of extra, rules that come into play with some of our exact values. So let's get stuck into it. In example 4, we're told that sine of theta, sine of some angle equals 0.3. And then we're being asked to evaluate cos of pi on 2 minus theta and cos of pi on 2 plus theta. So for the first part of this question, we're actually just going to use the rule that sine theta, and this is for any angle, is equal to cos of pi on 2 minus theta. And that's because sine and cosine are complementary functions. And so what that basically means is that cos of pi on 2 minus theta is going to be the same as sine of theta, which is 0.3. What's going on there, I guess, is that on the unit circle, when we think about how we read the values of cos theta off the x-axis and the value of sine theta from the y-axis, let's just say our angle is like a pretty small angle, maybe 10 degrees or something like that. That's going to kind of, well, that wasn't quite 10 degrees, but you get the idea. If that's our theta going that way, well, pi on 2 minus theta just means that you'd start from 90 degrees or pi on 2 up here and go the same distance the other way. And by symmetry, what really happens as you think about going from that point there to that point there, your sine and cosine values are just swapping. The x and y coordinates are just swapping around. And that's why sine of theta equals cos of pi on 2 minus theta. And also the other way around, cos of theta would equal sine of pi on 2 minus theta. In the next part of the question, where we have to work out cos of pi on 2 plus theta, well, what we're really doing now, instead of moving, I guess, from 90 degrees to the right along the unit circle, sorry, the shadow's in the way there. So instead of going from here and then subtracting theta, we're actually going to start from here and add theta. Now, again, you'll have to kind of excuse my not to scale drawing, but essentially all that's going to happen here is instead of being just to the right of the origin, we're going to be the same distance to the left of the origin. So the value of cos theta, or sorry, the value of cosine will be the same, just negative rather than positive. Okay, so in other words, we're saying that if you want it as a rule, cos of pi on 2 plus theta will actually equal negative cos of pi on 2 minus theta, which is negative, which is negative sine theta. Get the negative in there. So the answer, after all that, is just negative 0.3 because we knew that sine theta was 0.3. All right. Example 5 says, given that cos of pi on 7 is approximately equal to 0.9010, find sine of 5 pi on 14 using complementary angle properties. Well, okay, we have cos of an angle and we have sine of an angle. And we know that our complementary angle rule says that, well, let's say cos of theta equals sine of pi on 2 minus theta. And so in this question, our theta really is pi on 7, and that would be equal to sine of pi on 2 minus pi on 7. Well, sine of pi on 2 minus pi on 7 is actually 7 pi on 14 minus 2 pi on 14, which is actually 5 pi on 14, which is the angle or the value that we're trying to find. So in other words, sine of 5 pi on 14 is the same as cos of pi on 7, And so the value of sine of 5 pi on 14 is approximately 0.9010. All right, lucky last example in this section. We're told that cos of theta is 0.6 and 3 pi on 2 is less than theta, which is less than 2 pi. Find sine theta, hence or otherwise find the value of tan theta. So it's a two-part question, really. We have to find sine theta and we have to find tan theta. In any of these kinds of questions, if you know the value of cos theta and you're being asked to find sine theta, or the other way around, you can always go to the rule sine squared theta plus cos squared theta equals 1. Okay, that's called the Pythagorean identity. Easy to just say Pythag identity. The other thing that I guess is important to understand from the question is what that part of the question is telling us. All that's really saying is that our angle is in the fourth quadrant because it's between 3 pi on 2 and 2 pi. So our angle, theta, is somewhere in the fourth quadrant. Okay, so let's use this rule and put in what we know. We know that cos theta is 0.6, so sine squared theta plus 0.6 squared is equal to 1. Sine squared theta plus 0.36, because 0.6 times 0.6 gives you 0.36, is equal to 1. And if we're trying to work out sine, well, we're just trying to solve this equation for sine theta. Last step is to take the square root of both sides. We know that normally gives us two answers. So we know the square root of 64 is 8, so the square root of 0.64 is actually 0.8. The other thing that we have to decide is should this be positive or negative, because we've got two kind of possibilities, except we know from the fact that we're in the fourth quadrant, and this is a value of sine theta, that draw a little unit circle down here. If we're in the fourth quadrant, sine should be negative. Okay, so it's negative 0.8 since we're in the fourth quadrant. Whew, all right, so that's the first part of the question, to find sine theta. Second part of the question was to find tan theta. Now, there's a couple of ways you can do this, but in my opinion, the easiest way is to say, okay, well, now we have sine and we have cosine. We can say, again, let's put in red because it's I guess a formula here, that tan theta equals sine theta over cos theta. And so for tan theta, in this question, that's just equal to negative 0.8 over 0.6, which was given to us in the question, which is really negative 8 over 6, which is negative 4 on 3. So tan theta equals negative 4 on 3, and sine theta was negative 0.8.